Hello dear students, welcome to Konar classes. In this session, we are going to solve two questions on differential equations. Okay. The first question, as you see here it written in the board, solve the differential equation x dy minus y dx into y into sine y by x is equal to y dx plus x dy into x into cos y by x. So dear students, as we see that here it is y by x, let us see whether we can express that entire differential equation as dy dx is equal to a function of y by x. Let's see. If we can, then we can apply the concepts of that homogeneous differential equation. Let's see. Okay. Now, to find this y as a y by x, this y as y by x, what we can do is that we can divide both the sides of this equation by x square dx. That means what, dear students? What I can say is that from this given differential equation, we are going to get that x dy minus y dx divided by, here I am writing x dx into y by x. Okay, as I said that both sides we are going to divide by x square dx. So in the left hand side, x square dx we are distributing like this, x dx for this expression, and then for y it is y by x, and sine y by x we are keeping as it is. And right hand side, what we are going to get, dear students? The same manner, here we are writing y dx plus x dy divided by x dx into this x we are writing x by x and cos y by x. Correct? Now what we are going to get from here? So this implies that x dy by x dx, that is dy dx minus y dx by x dx, that is y by x into y by x into sine y by x as it is, that is equal to, in the right hand side we get y dx by x dx, that is y by x plus x dy by x dx, that is dy dx into x by x is 1 and cos y by x. Dear students, after that what we can do is that we see that apart from dy dx, everything is in terms of y by x. So we are able to express dy dx in the left hand side is equal to a function of y by x. How? Let's see it. Okay. So from here what we can write, dear students, that we write dy dx plus y by x. So dy dx plus y by x divided by this one, dy dx minus y by x, dy dx minus y by x is equal to dy dx minus y by x is multiplied with y by x into sine 1 by x, sine y by x. So I am writing here y by x into sine y by x divided by dy dx plus y by x is multiplied with cos y by x. So I am writing here cos y by x. Now from this equation we need to express dy dx in terms of y by x. How we can do this thing? We can use the concepts of componendo dividendo. If you recall what is componendo dividendo, let me write here. So if a by b is equal to c by d, then what you can conclude? That a plus b divided by a minus b is equal to c plus d divided by c minus d. This is known as componendo dividendo method, and you have learned it in your elementary mathematics during class 7 or 8 standard, correct? Now we are going to apply that. So what we are going to get, dear students, so this implies in the numerator we are going to get dy dx plus y by x plus dy dx minus y by x. So dy dx plus y by x plus dy dx minus y by x divided by dy dx plus y by x minus of dy dx minus y by x. That means what? We can write dy dx plus y by x minus of dy dx minus y by x. And in the right hand side, in the numerator it will be y by x sin y by x plus cos y by x, right? Y by x sin y by x plus cos y by x divided by y by x into sin y by x minus cos y by x, correct? We have applied componendo dividendo very well, okay? Now what we are going to get, dear students, is that from here let's do in the upper part of this board, okay? Let's do. So let me remove till this part. Dear students, you also do along with me, as I always instruct, then your learning will be complete. So from here what we are going to get, dear students, so this implies, if you see dy dx plus y by x plus dy dx minus y by x, so plus y by x minus y by x got cancelled. So in the denominator what we are going to get? 2 dy dx, correct? And in the denominator we see that dy dx minus dy dx we will get cancelled, and y by x minus of minus y by x means y by x plus y by x, that means 2 into y by x, correct? And in the right hand side what we get, dear students, whatever is written, y by x into sin 1 by y by x. So whatever is written, let me write it here. So y by x into sin y by x plus cos y by x divided by y by x into sin y by x minus cos y by x, okay? So now in the left hand side we see this 2 and 2 got cancelled. So what we get, dear students? So we get dy dx is equal to y by x. So this y by x I take it to the right hand side, and what we get? We get y by x into sin y by x plus cos y by x divided by y by x into sin y by x minus cos y by x, correct, dear students? Now if you look into the entire right hand side, this one, if you look into this entire right hand side, what we see, dear students, it is a function of y by x, or we can say it is a homogeneous function of degree 0 in y by x, because this entire thing is nothing but x to the power 0 into a function of y by x. If you recall, if we express a function fxy as x to the power 0 into another function of y by x, we say this function fxy is a homogeneous function of degree 0. And if we get this kind of situation, then we can apply the concepts of homogeneous differential equation to solve it. And what is that, dear students? We need to make a substitution like y equal to vx, correct? So let me write it here. So our substitution is y equal to vx. So let me write it down. So let me make the substitution a different color. Okay, let y equal to vx. This implies what, dear students? If we differentiate both sides with respect to x, we are going to get dy dx is equal to v plus x into dv dx, correct? Because product rule, ddx of vx means v into ddx of x, that is 1, that is why it is v, plus x into ddx of v, that is dv dx. Once we get this thing, dear students, we apply that value here, okay? Then what we are going to get it, dear students? So this implies instead of dy dx, we write v plus x into dv dx. So v plus x into dv dx, that is equal to, that is y by x equal to v, because y equal to vx, that means y by x equal to v. So v into what we get, v sin v plus cos v, v sin v plus cos v divided by v sin v minus cos v, v sin v minus cos v, correct? Now what we are going to do, dear students, is that we take this v in the right hand side. So from here what we get, so this implies x dv dx is equal to, if we take that v in the right hand side, then we can take v common. So what we are going to get, we are going to get v sin v plus cos v divided by v sin v minus cos v minus 1. I hope you got it. This v, we took it to the right hand side, and after that, that means it become minus v. When v, we take it to the right hand side, it become minus v. After that, from that minus v and this expression, we took v common. Then you get this, correct? So from here what we get, dear students? So from here, this implies that x dv dx is equal to v. So let me write in elaborate manner. The denominator is v sin v minus cos v, v sin v minus cos v, and in the numerator v sin v plus cos v, v sin v plus cos v minus v sin v plus cos v, because minus 1 is multiplied. So minus v sin v plus cos v. Now if we look into the right hand side, dear students, what we see that v sin v and minus v sin v will get cancelled, and cos v plus cos v will become 2 cos v in the numerator in the right hand side. So dear students, so what we can do is that from here we, so from this one we come to the this place. So this implies what? We get x dv dx, x dv dx is equal to v into 2 cos v, that means 2v cos v divided by, it is v sin v minus cos v, v sin v minus cos v, correct? So from here what you can write, dear students? So this implies if we take that v into the one side, that means v sin v minus cos v divided by 2v cos v into dv is equal to dx divided by x, correct? So this implies what, dear students? So we can take this 1 by 2 common here, we can take it outside. Then v and v will get cancelled, sin v by cos v will become tan v. Tan v minus cos v by v cos v, that will be 1 by v. 1 by b into dv is equal to dx by x. After that, what, dear students? So we take the integration of both the sides, correct? Now what we are going to get? So this implies in the left hand side what we get 1 by 2 into integration tan v dv, that is equal to what? Log of sec mod sec v. Log of mod sec v, that is from the formula, correct? Minus integration dv by v, that is log of mod v, minus log of mod v. Okay, that we can give only first bracket, that's fine. That is equal to log of mod x plus one integrating constant, as everything is in log, so let's take that integrating constant also as log of c1, where log c1 is an integrating constant. Okay, so what we are going to get from here, dear students? So this implies this 1 by 2, what we can do this thing, so that means log of sec v by v, log of mod sec v by v is equal to 2 log mod x, okay, plus 2 log mod c1, correct? Now if we take this 2 log mod x, that means what? Log mod of x square. So this implies what, dear students? So from here what we get, that is equal to log of mod sec v by v minus 2 log mod x is log of mod x square. Okay, so that means that we take in the left hand side, that become log of mod x square, that is equal to 2 log mod c1, correct? Now log m minus log n, that is log of m by n, that's the properties of logarithm. That implies log of mod sec b by v into x square is equal to 2 log mod c1, correct? We are almost there to that solution. Now, dear students, what we are going to do is that we need to apply back the value of v. What is v? V is y by x, correct? So we are going to apply that value here. Okay, so let's write it here. Okay, so what I am saying, dear students, so from this part we are now coming to this one here. So this implies, so log of mod sec v, that means sec of y by x, correct na? Because y equal to vx, that means v is equal to y by x divided by vx square, that means v is y by x into x square, that is equal to 2 log mod c1. From here what we get, dear students? So this implies log of mod sec y by x divided by y into x, or you can write x into y. This is equal to 2 log mod C1, correct? Now let's simplify it little bit, okay? So this implies what, dear students? This implies that sec y by x, we are removing the mod, divided by xy is equal to plus minus 2 log mod C1, correct? Now this plus minus 2 log mod C1, we are considering this as a new constant called C. So from here what we get, dear students? So sec of y by x is equal to Cxy. This is the solution to the given differential equation, where C is equal to plus minus 2 log mod C1. This is the solution to the given differential equation. Okay, dear students. Now let's proceed to the next question. Okay. Okay, so let me take this question from my notebook, okay, and let me write it down here, dear students. The question is that solve the differential equation tan inverse y minus x, tan inverse y minus x into dy is equal to 1 plus y square dx. Okay, dear students. So from the given differential equation, what we get, dear students? 1 plus y square into dx is equal to tan inverse y minus x into dy. Let's do one thing. Let's divide both sides by dy and 1 plus y square. That means what? In simple terms, we can say, let's take this dy here. That means it becomes dx dy. And let us take this 1 plus y square in the right hand side. That becomes what? Tan inverse y divided by 1 plus y square, correct, minus x by 1 plus y square, correct? And we are able to make this division since 1 plus y square cannot be equal to 0 and dy that can also not be equal to 0, correct? Now, dear students, what we are going to get? So this implies dx dy, okay, plus 1 by 1 plus y square into x is equal to tan inverse y divided by 1 plus y square. And this is an important position. Okay, why it is an important position, dear students? If we look into this particular differential equation at this point, what we can say, dear students, is that dx dy plus p1x is equal to q1, where p1 is a function of y, as if this is p1 and as if this is q1. If you recall, when we discussed linear differential equations, if we have a differential equation something like this, dx dy plus p1 into x is equal to q1, where p1 and q1 are either constant or functions of y only, then we call this is a linear differential equation, and here we need to find that integrating factor as e power integration p1 dy. After that you need to multiply both sides of the integrating factor and get the solution. If you want to know more about linear differential equations, please look into the previous sessions. Okay, it's all available in YouTube and the online test platform at konarclasses.com. So now what we get the integrating factor here, dear students? So we get the integrating factor as e power integration p1 dy, that means dy divided by 1 plus y square, that is equal to e power integration dy by 1 plus y square, that is tan inverse y. So e power tan inverse y. So now as we get the integrating factor as e power tan inverse y, what is the solution of this differential equation? The solution to this differential equation is x into the integrating factor. So from here what we get, x into the integrating factor, that is e power tan inverse y, okay, is equal to integration q1 into integrating factor dy. What is q1? q1 is tan inverse y divided by 1 plus y square, okay, into e power tan inverse y, correct, into dy. Whatever the solution to this integration, and we will add one integrating constant and we will get the solution to the given differential equation. Now we should concentrate where? We should concentrate in solving this integration, correct or not? So let us solve in this portion. So what I was telling, this integration, okay. So if we come to this portion, then how we are going to solve this integration? So let us take e power tan inverse y is equal to t, okay. Let e power tan inverse y is equal to t. Then what we get, dear students? So this implies if we differentiate both sides, we get left hand side e power tan inverse y into differentiation of tan inverse y, that is 1 by 1 plus y square, into 1 by 1 plus y square, okay, and that is equal to dt. Here I should write dy, okay. From in this integration, if we substitute this one, so what we are going to apply, dear students? So let's write this integration is equal to integration, what we write here, dear students? So write tan inverse y into e power tan inverse y, e power tan inverse y divided by 1 plus y square into dy, okay. This integration we have written like this. Now e power tan inverse y dy by 1 plus y square is nothing but dt. So this is equal to what? Integration tan inverse y dt. What is tan inverse y? As e power tan inverse y is equal to t, that means tan inverse y is equal to log d. So what we get, dear students? So instead of tan inverse y, we get log d, and instead of e power tan inverse y by 1 plus y square dy is nothing but dt. Now dear students, integration log d dt, integration by parts. So only one function, that is log t, which is not directly integrable, so we will consider this as a first function, and 1, nothing is multiplied means 1, na? 1 as the second function. So what we are going to get? So this is equal to log t into integration dt minus integration ddt of log d into integration dt and whole integration. Correct? Integration by parts. If you want to know more about integration by parts and how it is done, look into my previous lecture on integration. Okay. So this implies what? T log t. So what we get, dear students? So this is equal to t into log t minus ddt of log t minus, first we give integration, ddt of log t is what? 1 by t into integration dt, that is t dt. That implies what, dear students? So we get 1 by t into t, that means is actually 1 dt. So that is equal to what you can write here, t log t minus integration dt. So that is equal to t into log t minus t plus 1 integrating constant c. Now what is the value of t? That value of t is equal to e power tan inverse y. So that all you need to apply here, that's it. So what you can write here is that this is equal to t is equal to e power tan inverse y, e power tan inverse y, okay, into log t. Log t means tan inverse y into tan inverse y, okay, minus t. Minus t means what? E power tan inverse y. Now we can take this t common, that means e power tan inverse y common. Then what we are going to get? This is equal to tan inverse y minus 1 plus c. Let me repeat once more. From t log t minus t you can take t common, no? And t is nothing but e power tan inverse y. After taking t common, what we left with? Log t minus 1. Now if e power tan inverse y is equal to t, that means tan inverse y is nothing but log t. So log t is nothing but tan inverse y, that we have written here, minus 1 plus c. Now this value we need to apply here and done. We are done. So that means what? Whatever the value we get, whatever I am writing here in this black color, whatever I am enclosing it, this is the value of this integration. Okay. So what is the final solution we are going to get? Let me write it here. Okay. So if we take it from here, so this implies we get e x into e power tan inverse y is equal to, this entire integration is nothing but this e power tan inverse y, correct, into tan inverse y minus 1, tan inverse y minus 1 plus integrating constant c. Now what we can do is that we can multiply both sides by e power minus tan inverse y. So then what we are going to get? We are going to get x is equal to e power minus tan inverse y. So this will get cancelled. So we will get tan inverse y minus 1 plus c into e power minus tan inverse y. Okay. And we can write, because e power minus tan inverse y is not equal to 0. That's why we are able to multiply both sides. So now this is the solution to the given differential equation. X equal to tan inverse y minus 1 plus c into e power minus tan inverse y. Okay, dear students. With this note, let me conclude the class here. Now what is your task? Your task is to make relevant practices. And to make relevant practices, the best platform is the online test platform at konarclasses.com. Please look into the description section. You will get two presentations, one on the online test platform and one on the online learning platform. Look into it and then you will get all the relevant features. Okay, those who already have login, please log into the online test platform and perform DPP, that is daily practice problem. After that, perform PT, that is practice test. After that, perform UT, that is unit test. After that, perform MDT, that is module test. And finally, perform MT, that is mock test. In this way, in this sequential way, if you make your preparation is definitely going to be rock solid. Those who do not have account in the online test platform at konarkclasses.com, I will suggest first look into the features as given in the presentation, and the presentation link is provided in the description section, and then contact us. Thank you very much. Bye bye.